Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
And MAC address. MAC address of the switch. Correct. So bridge ID is nothing but it's a combination of priority plus MAC address of the switch. Okay. The one who is having the lowest bridge ID, that would be considered as a master. Most of the time, the priority number is always identical for all the switches. Then election process would be based on MAC address. Then whose MAC address is lowest, he would be the master. Technically speaking, priority number is same. So ultimately, if you combine it, so combination would be the MAC address plus priority number. So actually, it is working on this combination of two devices. I can change the priority of any device at any given point of a time if I want. Correct? But this is the first step to find out root bridge. Okay. Then how this election is happening actually? Now remember that when I connected all these devices together, everything was in amber color. Now that time what exactly happened? There is a protocol called as BPDU, that is nothing but Bridge Protocol Data Unit. Now this protocol is actually send signals to every 2 seconds. Okay, this is a by default behavior. But what exactly happened? Now it is confusing me. You said root bridge needs to be selected. Now in order to select that, we need to find out some election process. Now what is the criteria of this election process is the one who is having the lowest bridge ID, he would be my root bridge or he would be my master. Now what is a bridge ID? Bridge ID is nothing but a combination of priority number which is available on the switch along with the MAC address of the switch. Majority cases priority numbers are identical across the switches. Then the lowest MAC address would be the master, or I can call it as a root bridge. Now in order to perform this selection process, bridge protocol data unit is a protocol will help me. Actually when it was in amber color, that time BPDU traffic, means this traffic is generated by BPDU protocol, would be transferred across all the switches. And what he's transferring? He's transferring the bridge IDs. He will say, okay, this is my bridge ID. I will send it to you. Okay. He said, my bridge ID is this. I will send it to you. Give me your bridge ID. Same thing for here. Give me your bridge ID. I will send my bridge ID. He said, give me your bridge ID. I will send my bridge ID. Why they are sending the bridge ID in the BPDO traffic? Because I want to go for election process. I want to find out the root bridge. Correct? So in order to find out the root bridge, I need to send some BPDU traffic across all the switches. If I send this BPDU traffic across all the switches, what they are transferring? They are transferring the bridge ID of the switch. Why? Because I want to compare whether you are lower or mine is lower. Why? Because I want to find out root bridge. This is the first process. Now, why I want to find out the root bridge? Because if I find out the root bridge, this would be my reference point. I will refer this root bridge in order to avoid the looping. This is my reference point. Why I want to find out the root bridge? Because I want to consider this root bridge or the master switch, whoever is the master, as a reference point to avoid the looping by blocking the interface. This is the only purpose which we have. Correct. This is why I want to choose what? Bridge, root bridge. Correct. So when that particular umber color was there, this was the process. Listening. He is listening that BPDU traffic. Correct. Now that BPDU traffic contains what? That BPDU traffic contains the bridge ID. The bridge ID means priority number and the MAC address of your switch. The lowest bridge ID would be the root bridge. This is the first process why how STP work. This is what he actually do first. Correct. Now this is very important to find out the root bridge, because this root bridge would be able to have the reference number. Correct. Then that reference number would be the one which we can use. Correct. Now, once I'm selected the root bridge, I told you sometime I will show you actually. Okay. I go here, show spanning tree. You can see the priority number. Okay, this is the priority number of this switch. Now, root ID, this is the priority number. This is the information about your root bridge. That means this is not my root bridge. Correct. But look at, this is my priority number. And where is my MAC address? You will find under base Ethernet MAC address. This is the MAC address. So combine, I put the priority number and the MAC address. It is same. But if I see the priority number right now, the priority number is this one. Okay. Currently, don't worry about now. This is the switch, and the priority number of this switch is this. Correct. Technically speaking, this is the priority number of this switch. I will go to another switch and find out the priority of this switch. This is also the same. Okay, the priority number is also the same. I told you the priority number almost same for all the switches, correct? Now, if I go to this switch, let me see this priority number. Show spanning tree. This is the priority. Now look at this. This priority number, I told you that it is almost same. I can change this priority number if I want to do the election one more time. I can change the priority number of any switch. Once again, the election would be happened. Maybe that the new priority value switch could be root. I don't know. But currently, this is the priority of this all the switches. I told you root bridge. What is the process? He will go for the lowest bridge ID. Bridge ID is nothing but the priority number and the MAC address. Most of the time, the priority number would be same. Correct. Then he will check the MAC address of your switch. The lowest MAC address would be the master of your entire switches. Correct. Now let's find out who is actually master in our case, because I would like to take his as a reference point. He would be my reference point. Okay. Now you will see this is my master actually. This is the information about root ID. This is the information about my switch, correct? So it is connected to the port number 2 fast Ethernet. So which is port number 2 fast Ethernet? So it is connected. So 100% this is my bridge ID. I will show you there is a word show spanning. Currently this is not a bridge ID. It's root bridge, sorry. This would be my 100%. This is clearly mentioned. This bridge is root. So this is my master. This is what my master is. He is my root right now. That means in first election process, I come to know that the bridge ID of this particular switch would be something called as a basic, means at least value is there over here. And because of that, he is the master of this network right now. This is the first process. People ask me, if I change the bridge ID priority number of this to lower number, will it be a master? Yes. But if you do that, once again election process will happen. That means once again BPDU traffic would be shared across the network. And when the BPDU traffic shared across the network, once again listening, learning, and then forwarding. So it requires 30 seconds. If I change anything over here, once again for next 30 seconds, my traffic would be jammed. Because when BPDU traffic is going on, none of the other traffic would be allowed it over the network through switch. So be careful, correct? That's fine, no doubt about it. Now, what is the second thing which we are going to find out? Correct. The second thing would be selecting the root port. Okay. Now remember that this is called as my root bridge. Then these two switches would be called as non-root bridge. Okay. So this would be called as root bridge because he is my master now. Now everything would be taken with this reference. This is just a reference point I want, and that's the reason I'm selecting this. So this is my root bridge. So other switches would be considered as non-root bridge. Correct. Okay. This is my non-root bridge. Correct. Okay, so my first process is done. Now what next? Next process is to select the root port. Now root port means from this switch, how quickly I can go to this particular root bridge. I want to communicate from this switch and I want to reach to this switch. So I want to find out which port of this particular switch can directly get connected with my particular root bridge. Correct? But currently it is directly connected. In real life, it could be multiple ways around. I need to find out there are three ports: first port, second port, third port. Now this port would be always connected to the endpoint, so this port will not help us. Now out of these two ports, I believe this is a port number 1 and this is a port number 2. Which one would be root port? Root port means the port which is connected to the root bridge with the least value or best way to reach to the root bridge. That means this is the port which is port number 1 on this particular switch would be the best port to contact with the root bridge. This is the best port which is directly connected to the root bridge. Correct? Now, in order to select the root port, there are three criterias. Currently, it is connected directly. That's the reason it's the best port. But there are three different criterias, or there are three different rules in order to select the best port. Now, the first rule is.
Hey viewers, Our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Least cost. That means your speed to reach the root bridge or master. How much speed you are getting in order to create the master. Correct? The second rule, okay, now we will discuss about this rule first, then we will jump into the second rule. Correct? Now this rule will say what is the best cost. I want to find out the best cost. Now the cost, there are some default costs based on the speed. Okay. Now if I'm using the connection between the switches and the speed of that connection is 10 Mbps, then I will say the default cost of 10 Mbps is 100. Correct? If I'm having 100 Mbps connection speed between the switches, then I will say 19. Most of the time you will find 100 Mbps only. Okay. Then I do have only 1 Gbps speed, then the cost is 4. 10 Gbps speed, the cost is 10. Remember that this is the first case, or this is the first criteria in order to choose the root port. Root port means on my switch I want to find out such a Ethernet port which can help me to find out the fastest way, the best path to reach to my root bridge. This is the second thing which I'm doing. Under second thing, this is the first criteria. Correct? Let's say I do have a speed between these two is 100 Mbps. Okay, which is a 100 Mbps connection speed. Here also I am having 100 Mbps. Okay, here also I am having 100 Mbps. Correct? Now why this is my root port, I will tell you. Why this switch is selected, this would be the fastest way to reach to my root bridge. This is the first rule to find out the root port. What this port says, if you are getting the 100 Mbps speed, then the cost of this connection would be what? 19. Correct? Now this is my first way to contact my root bridge. What is the another way? There is this way. I can contact to this switch and I can go to this master. But what is the cost of this? 19 plus 19. That means how much? 38. So which is the least one? The least one is nothing but this 19. So I can choose this would be what this would be my root port because I have a cost of only 19. If I go through this particular port, then I need to go to this would be 19. Then I would like to go to this would be 19. So total cost value would be 38.
Mangesh, I have a small
Yes,
doubt.
yes.
Yeah, when we follow that least cost speed to reach the root bridge, that thing, in the
Mhm.
default cost, the value of 10 Gbps should be less than the value for 1 Gbps, right?
Okay, now I will tell you now, these people who develop this particular protocol, these values are predefined. Okay,
Okay.
so these are standard value. Okay, based
Yeah.
STP is an algorithm, to be honest with you. And
Okay.
when they develop this algorithm, these are the default values, which is provided by Cisco. You
Okay.
cannot define it. It is by default based on the speed. Now, technically speaking, 1 Gbps is the lower cost and 10 Gbps is the higher cost. But this is
Yeah.
how it is. Correct?
Okay.
They will calculate based on that. Okay. So you
Okay.
cannot see that this is a default cost which they are calculated, correct? Because 10
Yeah.
Gbps connects 10 Gbps connections would be very, very less. I told you 10 Gbps Ethernet card are very, very expensive. You can
Yeah.
see if the interface card is so much expensive, what would be the cost of the 24 port of the router? Every port is 10 Gbps. So I
Yeah.
cannot use 10 Gbps switches on my normal. This is access layer switches. 10 Gbps switches where I can use backbones. Majorly core switches are required where all the traffic is required. So that time I can use this. Correct.
Okay.
So these are the default cost
Okay.
which we cannot modify. It is based on the speeds. Clear?
Okay. Yeah.
So
Yeah.
I just
Thank you.
okay, thank you. So I just want to select that which port is the fastest one, which port is my root port. Root port means what? How do I reach to the root bridge in a fastest way? So if I go to this particular port, the port number is nothing but this port number of the switch, port number 1. The cost, if I try to reach to the root port, the cost would be 19. But if I go from this particular port, the cost would be 38. Why? 19 plus 19. So what is the best path? This one. So what is the most root port for my this switch? Would be fast Ethernet 1. So this is my first criteria. Now in some cases, what if the cost is same? I will give you the case. I will tell you one scenario, okay, where I will see whatever cost factor which we have done. In certain cases, it would be same. Let's take an example. Oh, not a router, switch. Okay, now look at this case. Okay, now look at this case. Interesting. Now, if I want to consider this is my master, okay, and this is the switch, correct? This is my master, or you can say root bridge, correct? You can say this is my master, this is my, or you can say root bridge, anything. But for understanding, I always use the master word that people would understand it. This is my master, correct? Now look at the cost to reach from this point. Now this is again a port on this switch. This is 2 port, correct? Now if I say the least cost based on the speed, correct? Now in this particular scenario, what is the value over here? 19. What is the value over here? 19. What is the value over here? 19 and 19. So consider this case for this switch. Now this switch is get confused because what is my first criteria? Least cost. But currently the cost of both the side is 38. It is a tiebreaker. Now how I am going to choose which port I need to use as a root port? Which one is the faster? Technically speaking, both the cost is 38. So the first criteria in order to choose the root port, cost, I cannot choose it because it is a tiebreaker there, correct? Then there is a second rule. Okay, look at what second rule says. I will write that rule under here only. Okay, the second rule to find out the root port is the lowest forwarding switch ID. Now don't get confused, I will explain. Okay, the lowest forwarding switch ID, correct? Once again, it is the same thing. It is talking about bridge ID. It is a priority number and MAC address, but he's talking about forwarding switch. Now, if I consider this particular scenario where cost is equal, I cannot do find out the best port because the cost is 38. Then he will understand currently I'm not directly connected to the switch. I need to go through some upstream router, sorry, upstream switches. These are what mine, these are upstream switches, correct? Now what rule says the lowest forwarding switch ID, that what he is actually doing, he will say tell me whose bridge ID means priority number and MAC address. So he will check the priority number and MAC address of this switch because this is my forwarding switch. This is my forwarding switch. He is the one who is going to forward my request to the root, to the master. So he will check in the case of tiebacker in the cost, my second criteria to choose the root port is the switch ID of these upstream switches. Now switch ID means once again condition is same, priority number and MAC address. The one who is having the lowest switch ID, I will choose the path to connect to that. So I would be choosing this particular path or this particular port as a root port because the switch ID of this switch would be lower. So my second criteria to choose the root port would be the one which is having the lowest switch ID. Switch ID is nothing but priority number and MAC address. Now 100% priority number is equal, then the tiebacker in this particular condition would be MAC address, correct? Okay, let's say I agree. Now is there any chance that there is a tiebacker in bridge and MAC address? Then what we supposed to do? Okay, there is a condition. Now look at the third rule. Okay, I will take, okay, this is my master switch, this is the second switch, okay, and this is a third switch. If I connected something like this, then what? Then how do I find out the root port? Look at the cost wise. Cost wise, once again, if I go from this side to this side, 19 plus 19, 38. So my cost criteria would be once again a tiebacker. If I go from here to here, once again, cost is 38. That means this criteria is there. Now you said go for second criteria, go to the upstream router, upstream switch and find out the MAC address and priority number. That means switch ID. The lowest switch ID would be the point where it is connected, it would be root port. Now in this case, that is a single, that means I cannot do that criteria as well. So there is also tiebreaker in my second rule, the lowest forwarding switch ID. Then what is the third criteria? The third criteria to find out the root port is okay, the lowest forwarding physical port number. Correct? This is the third criteria. Correct? In order to find out the root port. Now, according to this, if this is connected to the port number 1 and this is fortunately connected to the port number 2, correct? So he will check the port number of upstream switch. He will check this port is connected to the port number 1, this port is connected to the port number 3. So he will find out the based on the lowest port number of your upstream switch. He is not going to consider anything from here. He will check this is connected to the port number 1, this is connected to the port number 3. If my both the criterias are tied, then he will say the low. Okay, my both the criterias are tied. The cost wise 38. I cannot do the tiebreaker on bridge ID and priority number and MAC address because it's a single switch. Then how do I find out the best root port over here? Then look at your upstream switch.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
The lowest port number would be your by default root port over here. So this is my root port in order to connect to the root bridge. Correct? So understand this is little bit complex when you are dealing it for the first time. To be honest, you are not supposed to do any changes for this behavior. This is by default STP algorithm works in this format. You just need to understand you're not supposed to configure anything at all with this, and this particular thing would be just automatically happens. Correct? Now this is something very important. Correct? So second step is done. Okay, I find out that which port needs to be a root port. Correct? So these are the three criteria, these are the three rules in order to correct the root port. Correct? Now understand the third thing. What is our third thing? Selecting designated port. Designated port means the port which we are going to use for forwarding, and non-designated ports which we can use it for blocking. That means which port needs to be forward and which port needs to be blocked. Correct? Now here they are once again going to understand two important terms. The root port which is selected on any particular switch. Correct? Remember that the root port which is selected on any particular switch. Correct? Those you will not be able to block. Okay, that means this root port you cannot able to block. This root port of this particular switch cannot able to block. On the master you cannot block anything because all are root ports for the master. On non-root bridge means non-master switches, the root port which you have selected, you cannot block these root ports because these are the fastest way to reach. Then I do have alternate port, but why it is selected this port to be blocked? Why cannot this? Okay, you can see where it is connected. It is connected to fast Ethernet 2. This is connected to the fast Ethernet 1. Why should I block this one? Why cannot this? Okay, once again tiebreaker. He will check the MAC address of that local port. Remember that the local bridge ID they can say now. Remember guys, every switch do have its base MAC address. Along with that, every port, remember what I'm saying, every port do have their local bridge ID. Once again, what is a bridge ID? Priority number and MAC address. Then which MAC address they are going to talk about? They are going to talk about the MAC address of that particular port. Correct? Okay. So once again, the tiebreaker would be happen with the local bridge ID. Then whose bridge ID is the lowest one? Correct. He would be open and the highest one would be blocked. Correct. So this is how STP will find out which one I need to block and which one I need to open. But any given point of time, I cannot be able to send any traffic from here to here. This switch cannot be able to send any traffic from here to here. Correct? Now look at carefully one more time. What is my first step? The first step is to find out the root bridge, who is the master in these three switches. Why I want to choose the master? Master is only for reference point to decide which port I need to open and which port I need to block. Correct? Then how do I choose the master basically? The master would be selected with the help of election process. The election process is nothing but BPDU traffic would be transferred across the switches, and that BPDU contain the bridge ID of the switch. Now bridge ID is base MAC address plus priority number of the switch. That bridge ID which is transferred across the switches, they will start comparing with each other and they will find out, okay, who is the master in this particular network. Once we got the master, then I will take that particular master as a reference point and will do the next step. The next step is to find out the root port on every switch, the port which you can fastest way to connect to the master. Now there are three criteria to choose the root port. The first criteria is the cost. What is the cost would be available to reach to the master? Correct. Now cost is depend upon speed. What is the Ethernet speed, wires or media which you are using based on that? Correct. Sometime the cost would be same. Then what is the criteria? The bridge ID of your upstream switch. Whatever upper switch which you are using, try to understand the bridge ID, and the tiebreaker would be done with the help of bridge ID. Once again, bridge ID is nothing but MAC address and your particular priority number. If I'm getting the tiebreaker for the second condition as well, then look at the lowest port number on which your switch port is connected. But I'm not looking at the port at the downstream, it is once again upstream. Correct? So understand, this is the criteria to create the root port. Once we understand the root port, then I will check that root port should not be blocked on each and every switch, because this is the port to which I can connect to master. On the master, nothing is blocked. You can see nothing is blocked in the master side. Correct? Then I need to find out which port I need to block from this switch, whether I should block this port or whether I should block this port. Once again, the comparison would be happen with local bridge ID. The priority number and local MAC address of that particular port. The least one, the least one will get selected and other will get blocked. Correct? So this is the three-step process how STP works. Now this for entire process of doing that election, choosing that particular process, this process would be done by STP protocol, and it required at least 50 seconds to do it. 50, officially it is 40 seconds, practically we have seen. 15 seconds is required for listening, learning, and 10 seconds for forwarding. Correct? So this is very important thing to understand. Now, if I go to this switch, okay, and shut down this particular port, this port number is what? Port number 1. This is the root port. If I shut down this particular port, in order to switch over to this particular port, which is connected to the switch directly, this port is shut down. I need to switch over to this port, and this port is on the same switch. It required 30 seconds. How much time it's required? If port is called as failure time on the switch where ports are connected, failure time on the switch where ports are on the single switch. So it is called as direct line. It is called as direct line because my failure port is over here. I am shutting down this particular port. Automatically the failure would be happen. The port which is getting failed over, both are on the same switch. The one who is getting failed and the one who is getting up, both are the part of the same switch. Then it will take 30 seconds for failover or switch over, whatever. So if I go to this particular switch and I will shut down this particular port, you will see what happens. Enable CONT interfaced fast Ethernet 0/1, and I will say shutdown. Okay, you can see once again they are trying to find out which one is the best path. Correct? Now till the time, if you can see, I will show you. I will try to ping this to this and I will do switchover. The moment he will do the switchover, it required 30 seconds. Until that 30-second BPDU traffic was moving, okay, you can say it is turned on. And he will not allow you any other traffic to run inside your system. Correct? So I will show you, I will set one IP address over here. Okay. 1.100. Okay. So what I will do, I will ping continuously ping -t 192.168.1.200. Okay, it's doing it good. Now I will take the switch and my computer at the same time. Now my port is shut down. I would be turn it back on. Once again switchover would be happen. This particular is green. It will once again blocked and switchover would be happen. I will say no. Sorry. Okay. Now you can see once again BPDU traffic starts sending it till the time your network is down over here. It is requesting. The moment you switch over is happened, your switch will start sending the normal traffic. He will start sending only BPDU traffic, and the switchover would be happen between these 2 points, and both the point is connected to the same switch. It will take 30 seconds because direct failure would be happened. Correct? Now imagine I will do indirect. Now if I say, if I turned off this port, now this is indirect. Correct? Now here I required 50 seconds for switchover because this particular route bridge is continuously sending BPDU traffic for every 2 seconds. Correct? Every 2 seconds, he's sending some traffic in order to check whether the topology is correct or not, whether I am the only root. There is no one is else who is just connected and he is having the lowest bridge ID. Correct? So if I have such kind of situation, then I would be able to keep messaging the BPDU traffic across the switches. If I just stop this one, immediately you will get a response from the root. If I shut down this, he won't be able to send a BPDU traffic which is happening every 2 seconds. So immediately failure would be happened. So it required 30 seconds. But if I shut down this, he will start sending the BPDU traffic for 20 seconds. If he is not getting any response, then he will start the failover thing actually. So 30 seconds for listening and learning plus additional 20 seconds because he keeps sending the BPDU traffic over here.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Correct? So this is a problem for indirect failure. Now this is something which is happening in a normal spanning tree protocol. The spanning tree protocol which we are using, it is nothing but it is, I will show you which spanning tree protocol we are using. I go exit, show spanning tree, show running. Okay, the spanning tree mode is PVST, per VLAN spanning tree protocol. So this is the protocol which is currently I'm using. So default behavior of this particular protocol is it required maximum 50 seconds to do the switchover if the indirect lines are disconnected. 30 seconds if the direct lines are disconnected. Correct? Agree, no problem. Now, is there any chance that some people can take the advantage of this behavior of spanning tree protocol? Yes, there is a chance. What if I can change the priority of this switch which is available over here? I will go here and if I say enable, I will say config T spanning tree. Okay, you can say VLAN priority. Okay, what is a by default VLAN is 1, and I will change the priority. I can change the priority to 0. If the priority is 0, then what will happen? Once again, election would be happen and he will become a root. Am I right? If I have something software who can continuously do these things, then what? It's a problem. Correct? The person who is a layer 2 attacker, he can do something intentionally. Sometimes he say, let's change the priority number. Let's make the entire network down for next 50 seconds. And if you are using OLTP transaction, I told you a 1 second downtime would be hamper a lot of cost. Correct? Now, this is the problem in this case. Correct? Now there is a concept called as root guard. What I will say, root guard. I will save this root. There is a concept called as root guard. Correct? We will see how to configure the root guard. Correct? There is one more concept is available, which is called as port fast. this is happened on normal end devices. There is a concept, there is another thing is called as BPDU guard or BPDU filter. Now this is necessary if you configured port fast, you have to configure either these two options. There is one more concept is there. I can select one as a primary route and second one as a secondary route. If this particular things is failed due to some technical reason, I remove that particular switch. So automatically this will become the master. The election would not happen. Ultimately, I am telling that you are a master. Correct? So let's understand this is my root bridge. Correct? These are my root ports. These are my root ports where I'm sending the BPDU traffic to everyone and receive the BPDU traffic from everyone. Now I'm just telling him that I'm the master. Are you have any changes in a topology or not? Correct? Now what I'm planning with the root guard is I will guard these two traffic ports and I will change the priority number of this. The moment I change the priority number of this particular switch, he will start sending the BPDU traffic and saying, I am the new root, but he should block that BPDU traffic by saying that whatever BPDU traffic you are sending, you can keep it with you. I'm not interested to process your BPDU traffic at all. So he will stop any BPDU traffic which is coming from other switches. Correct? So he will be root only. He will not allow other particular switch to send any BPDU traffic and become a root bridge. Correct? So that concept is called as root guard. Okay. So if I say currently, let me see, I want to see what is a show. Okay. Do show spanning tree. Correct. Current the priority value is what? 32769. This is the priority value. Correct. Of this switch number 4. Correct. Now if I say conf t, correct, spanning tree VLAN 1 priority 0. I change the priority. See what you can see. Is doing the election one more time, because if I say do show spanning tree, what is he now? He is my root. Earlier he was our root, but right now he will become our root. Why? Because I changed the priority value. Once again the election is happening. Once again he's there trying to find out the bridge ID, and his bridge ID is actually lowest one because I remove the bridge ID into 0. I want to stop this. I don't want anyone who can send me the BPDU traffic. That's why I want root guard. So I will once again change this value. Let me see whether it's a bridge or not. This is also okay. Once again, he will become a root. Okay, he will become a root. So I don't want anybody can change the priority and stop my entire network for 40 seconds. Correct. Otherwise, anybody can come and fire the command and stop that. I don't want to do that. So that's the reason we do have an option called as root guard. This root guard option is only applicable on the root bridge, and I need to put that option to these two interfaces. Okay, what is this interface? Fast Ethernet 02 and Fast Ethernet 03. These are the two root interfaces on the root side. Correct. So we would change that. Okay, I will go here. Now I will fire the command called as interface Fast Ethernet 0/2 3. Well, Fast Ethernet range command is missing. Okay, so I'm into that Fast Ethernet thing. Now I would like to say spanning tree. Correct. If I say there is an option called as guard. Correct. I will say guard. I would like to say root. Correct. Press enter. So I have configured the root guard feature on this particular port. Now, if I try to send a BPDU traffic from here, now BPDU traffic is only allowed from this switch. No one else can send me any BPDU. He's the only one who can send me that. Correct. So if I go here, and once again I will change the priority number to 0. You can see it should be blocked. Why? Because he want to become a root. That's the reason he changed the priority, and he's sending that particular BPDU signal, but I'm not allowing him to become a root. I stop processing his BPDU traffic. Correct. So this feature is called as root guard. I'm making this particular root as a safer, so it will not become this. Now I need to manually, you can see root guard. Someone is trying to send me some BPDU message, and this particular BPDU message will stop him. So root guard comes into the picture. Now I need to manually say no shut here. Down. Okay, wait for some time to make it happen. Okay, this is called as a root guard feature. Now we will see the port fast feature and BPDU guard and BPDU filter. Now BPDU filter is not available in simulator. In real life it is available. Okay, and then we are interested to go for another version of spanning tree protocol is called as rapid spanning tree protocol. This is the one which is currently available in all the switches. It is rapid spanning tree protocol because it is switch over is very fast. Now I am once again coming back to the normal. Now what is a port fast and why we want to use it? Okay, now let's take an example of this computer. Correct. If I connect a server, if it is an end computer, that's fine. For example, I connect a server over here. Correct. Now this server is nothing but a database server. This is a database server, and I connected this server in my organization people to access the database. I will give the IP address 192.168.1.25. Now look at the things carefully. If I connect the wire to this computer, I will go to the switch. Okay, I will exit out of it and fire the command called as show spanning tree. You can see there is a process called as listening. Correct? Currently, this port number 4 is in listening state and it is still in the amber color at this moment of time. Correct? Now it is turning to the learning because our STP protocol works on listening, learning, and now it will become forward. Correct? Now remember that this particular behavior, if it is connected to the normal computer, it is okay. But the point when it is connected to the server, this behavior is somewhat problematic. By mistake, for example, by mistake, while doing troubleshooting, I unplug this cable. Okay, I unplugged it. If it is connected port number 4, I unplug this cable. And immediately I connected back to the port number 4. But what happened? Once again, listening, learning, 30 seconds. And then it will become a forwarding. Why? Because STP is running. STP is running on every particular port. Correct? So he is taking 30 seconds to make your traffic enable. Now 30 seconds, your server is down.
Thanks for watching. Want to study further? Join our training programs today.